okay? All right, so these are all word problems. It's growth and decay. You guys, I know in the past you've seen growth and decay word problems. This is gonna look really similar, like the equations are gonna look similar. In fact, that's why I only have a couple examples, because I know you guys have seen this sort of stuff before. It's really just like a review. Growth and decay models. So let's start with this. Rate of change y, so dy dt is proportional to ky. That kind of leads us, I should just show all of this right now. That kind of leads us into this. I think the main things that you want to get in your notes are obviously this part up here, but this part, draw, this part down here, that equation is what we're going to use pretty much on every problem. This right here. Yeah, that's this y equals c e raised to the kt. Okay. One thing that I want to do with this equation is use a different form of it, one that you guys are way more used to. We've all seen this, right? PERT. Worked with that before, seen that before, the PERT equation. This is the same thing as this. It's the same model, it's just different variables. So I think on these word problems, just because this is something that you guys are more used to, I'm gonna stick with this one, just because the variables might make more sense. But these are the equations, that's the equation we're gonna use when we're modeling exponential growth and decay. Okay. If you've written this equation in your notes, just know that A is like your final amount, right? And when you've seen this before, you may have seen it when it comes to like compound interest problems or money and stuff like that. But you can, I mean, you can use this in a lot of different places. P is like your beginning amount, final amount, beginning amount. R is your rate. Okay, and T is your time. So there's always gonna be something missing. You're gonna have to find rate, you're gonna have to find time, or you're gonna have to find your starting amount, you're gonna have to find your ending amount. It all depends on what the question's asking, but all you really need is this equation, okay? And actually, we're not gonna, for the purposes of this quiz, and just because like we're kind of cramming this in the last day before the quiz here, we're not actually doing any integration or anything. We're just using this equation. Again, probably pretty similar to what you guys have seen in the past. I only have 2 examples. I don't have it typed out or written out for you though, so you may want to take a minute to write the actual problem in your notes. Okay, half-life that deals with exponential growth and decay, so we can use the PERT equation. So just to start, let's figure out what we have and what we don't have, okay? Let me plug in, you don't have to write this next step down. I just want to show you like what variables we're missing. It says half-life of plutonium is 24,000 years. 3 grams of the plutonium sits for 1,000 years. So let's say 3 grams is like what we're starting with, right? So let's say I have A equals, because that's my finished amount. I'm starting with 3 grams. How many grams of the original amount is left? So it's asking like, what's the final amount? But it's not giving us a rate, okay? It's telling us it sits for 1,000 years, but it's not giving us a rate or it's not giving us a final amount, right? Because we have to solve for this. It's not giving us the rate. So what you have to do on all these problems or most of these problems is use the equation once to find one of your missing pieces, plug it back in to get your final answer. So what I'm going to do is I'm going to say, this says half-life. Whenever you see half-life, it means your end amount is half of what your original amount is. So if I start by saying I'm going to find my rate, so I'm in step 1 right here. I'm going to say 0.5 is equal to 1, right? Half-life means I'm left with half of what I started with. E raised to the R. Now, in order to use this half-life with plutonium is 24,000 years. So I would write 24,000 as my time. Okay. And you're just solving for R at this point, because once we have R, then we can plug it back in and find our A. So if I divide out my 1, I get 0.5 equals E to the R times 24,000. And then just like with differential equations, if I want to solve for my Y, in this case, I'm solving for my R, I want to get rid of this E, right? So I need to take the natural log of both sides. Okay, so like that. And then, so I'd have natural log of 0.5 is equal to R times 24,000. So let's leave it. We're not actually going to get the decimal yet. We're going to leave it like this. Natural log of 0.5 over 24,000 equals R. Okay. Now we have our R. Now we can use that in our original equation to go back to this question, because that's step 2. Now we can rewrite the original function, our PERT equation. Now let's do that over here. This is going to be step 2. To answer the actual question, how many grams of the original amount is left? So my final amount, we're going to call that A. The original amount was 3. We just used the half-life to find R, but now we're going back to the original actual question. Is 3e to the, now I have R. So this is going to be, my R is natural log 0.5 over 24,000 times T. It sits for what, 1,000 years? So it looks like 1,000 is going to be my T. Now this is something you would do obviously in your calculator, right? I would probably plug this in first and then take E to the answer, E to the previous answer, then times 3, and then get your final answer. If you guys, let's just try to do this in our calculator so I make sure like everyone's pushing the right buttons and everything, using parentheses. Yeah, and yeah, and actually E is right, should be right above it. Yeah, and E is right above ln.
E is the second of the division sign. It's not above ln. Oh wait, it is. Never mind.
Yeah. You should be getting 2.915 grams. If you can't find it, the keys, or if you're not getting it, let me know. All right, so that's a half-life question. That's like one type of question you'll see. I'll do one more. Okay. Any questions? Do you guys at least feel like comfortable using this equation? You guys have like used this before, right? Yeah, okay, good. All right, when you're ready, I'll flip the slide. We'll do our last one. Again, I'll give you a minute or so to write the problem down. This one's a little bit longer. Okay, questions asking, what will the sale be after another 2 months? They're giving you time, right? The 4 months and the 2 months. They're giving you, you're kind of missing a few things though. You're missing the rate of decline, right? They don't tell you anything in here what your R would be, like 0.8, 0.9, whatever. It doesn't tell you anything about rate in here. It also doesn't tell you what your final, what it will be after another 2 months. So you're really missing two things. Again, your A and your R. So it's really the same steps. You want to go in search of your rate first. So step one would be using the information that we have right here, the 1,000 and the 80, or 100,000, 80,000, we can find what our R is, right? So it dropped from 100,000 to 80,000. So let's say 80,000 was our finished amount. And we started with 100,000. And this is where we're going to find R, because it's telling us to drop that amount in, what was it? 4 months. Thank you. 4 months. another thing that you want to make sure of when you're doing these problems, make sure that your time is always the same. Otherwise, you're going to have to do a conversion. This is 4 months, 2 months. So it looks like our time is all the same because there's going to be some problems that have months. Like first it'll say months, then it'll say years, or first it'll say seconds, then it'll say minutes, and you have to do like a conversion. But in this case, we're good. So you would divide out, right? So you get the 0.8 equals e to the r times 4. I just divided the 100,000 on both sides. And then take the natural log of both sides because we want to get rid of the e. So then this would be natural log of 0.8 equals r times 4. So then r is equal to natural log 0.8 divided by 4. That's all step 1, and then be ready for step 2, which is going to be answering the actual question. What will the sale be after another 2 months? So we're looking for our final amount. Sometimes they ask you for original, sometimes they ask you for your final, and both of these are asking you for your final. Okay, so now the question is, what is my P? Is my P 1,000 or is my P 80,000 or 100,000? If you use 100,000 as your P, you'd have to set your time. I'm going to run out of room here. This would be natural log raised to natural log 0.8 over 4. You'd have to set your time equal to, so I started at 100,000. After 4 months, I dropped to 80,000. What will it be after another 2 months? So the 4 months and the 2 months from the beginning would be the 6 months. Okay, so if you're starting with, put the comma in the wrong place here, not 10,000, it should be 100,000. There we go. And again, this is one that you don't have to do any really dividing or anything out. You just have to plug it into your calculator. So again, if you did that, so it looks like most of you got the first one. So I would trust you to get the second one. Would be roughly 71,554 units. Did I put units on my first one? Yep, I did, grams. Just make sure, like on your quiz, you want to make sure you have units in your final answer.